Okay, today we want to present about the hydrodynamic. The code number of course is DCC 30122 fuel mechanical. My lecturer name is Wanjila Suana binti Ramli. Group member. My name is Kisan Rao, son of Sivakumar. My number matrix is 16 DK821 F1004.
My name is Nurul Atika Nabila binti Nur Azman. My metric number is 16DKA20F2025.
My name is Muhammad Syed Iskandar bin Muhammad Adham. My matrix number is 16 DKA 21F1012. Firstly, introduction. Reynolds number is referred as RE. Reynolds number is a dimensionless quantity which is used in fluid mechanics to predict the flow pattern in different fluid flow conditions. It is defined as a ratio of inertial force to viscosity force within the fluid. Fluid flow is a part of fluid mechanics and deals with fluid dynamics. It involves the motion of fluid subjected to unbalanced forces. This motion continues as long as unbalanced forces are applied. For example, if you are pouring water from a mug, the velocity of water is very high over the lips, moderately high approaching the lips, and very low at the bottom of the mug. The unbalanced force is gravity, and the flow continues as long as the water is available and the mug is tilted.
Okay, now I'm going to talk about classification of fluid flow. We have four types of fluid flow. First of all is uniform flow. Uniform flow ialah aliran seragam. Aliran seragam terjadi apabila tidak ada perubahan variabel aliran dari satu titik ke titik yang lain di sepanjang saluran. Non-uniform flow ialah aliran tidak seragam. Aliran tidak seragam adalah aliran yang ada perubahan variabel dari satu titik ke titik yang lain di sepanjang saluran. Seterusnya ialah steady flow. Steady flow adalah aliran mantap. Aliran mantap terjadi jika variabel aliran di sepanjang titik pada cecair tidak berubah dengan waktu. Yang terakhir adalah unsteady flow. Unsteady flow ialah aliran tidak mantap. Terjadi jika variabel aliran di sepanjang titik pada cecair berubah dengan waktu. Seterusnya.
There are three types of fuel flow. Lamina. Lamina is a flow in the laminar regime. Its flow is behavior as very easy to visible to and understand. The flow is driven entirely by internal force, which are usually just gravity and the driving pressure. Laminar flow is sometimes characterized as only occurring in incompressible, invisible fuel. This is incorrect. For turbulent flow, the turbulent flow is at the another end of the flow spectrum in corresponding to very fast flow rate. Turbulent is one of the most mathematically complex area of fluid dynamics. Generally require numeric technology and specific model to the examine flow behavior. When turbulence arises, fuel flow becomes the connectivity during the flow. Transitional flow, the Reynolds number values called a transitional regional whenever the flow behavior beginning to change to the laminar flow to the turbulent flow. This should underscore that there are no sharp dividing line between the laminar regime and turbulent. The type of behavior observer, the turbulent flow actually become dominant at higher dynamic number. The transverse flow is a mixture of the laminar and turbulent flow, with the turbulent flow is a second of pi and laminar flow are near to the angle. Each of the following behavior is different manner and term of the friction energy lost by following and have different equation for the predict the behavior. R is the dynamic number, P is the density of the fuel, V is the velocity of fuel, D is the pipe of diameter, this symbol is velocity of the fuel.
Problem 1. A Newtonian fluid with a dynamic viscosity of 0.52 Newton second per meter square with a density of fluid 980 kilograms per meter cube flows through a 50 millimeters diameter pipe with a velocity of 2.6 meter per second. Determine the type of flow Reynolds number. Solution. We're going to use a Reynolds number formula, which is RE equal to density by velocity by diameter per viscosity. Viscosity equal to 0.52 Newton second per meter square. Density 980 kilograms per meter cube. Diameter 50 millimeters. And velocity is 2.6 meter per second. Then we arrange the data according to the formula, which is RE equal to 918 in bracket 2.6 by 0.05 per 0.52 equal to 127.4 per 0.52. And lastly, we got 245, which is a laminar flow.
Okay, I want to go to the problem 2. The Newtonic fuel with the dynamic velocity of the 0.14 Newton per second per meter cube, meter square, and the specific gravity of 0.96 flow, although 28 diameter of pipe with a velocity of 2.9 meter per second. So the solution is we use the equal to the density velocity diameter per kilometer is 0.4 Newton per second per meter square. In the question they gave specific gravity. Specific gravity is 0.96. The diameter of pipe is 28 millimeter. The velocity is 22.9 meter per second. So the solution, the density can be calculated using the specific gravity like 0.93 times 1000 kg per meter cube. So we can get 913 kg per meter cube. So the density is 913 kg per meter cube. The Renault numbers can be calculated using the formula as Renault. The formula is Re per density, volume, diameter per kinetic velocity. So we take the all equation and we get 913 times by 2.9 times by 28 millimeter times by 10 times divide by 0.39, we get 139 kg per meter second per cube. So the flow is laminar flow because the flow is under the 2000.
This is video of dye visualization method. Firstly, it's a laminar flow. Then time to time, it will change to a transition flow. This is transition flow, which is wavy line of ink. Lastly, it will change to a turbulent flow, which the ink is swirling in the pipe.
Okay, conclusion. This hydrodynamic is very necessary in daily life because what we do is mostly hydrodynamic elements. From this topic 3, we can learn the concepts in hydrodynamics in more detail. For example, real fluid, ideal fluid, compressible, incompressible, and others. Here we can also learn how to calculate the Reynolds number easily because we have learned the formula and how to calculate it. It is not too difficult if we are accustomed to using the formula that has been provided.